Question 2. Design of square footing. This footing embedded at 2 meters below the ground surface. It looks like this. It has a width of 2 meters by 2 meters. And this is the ground surface. And the embedment depth, 2 meters. We're given vertical load, P, and 2 bending moment. For x-axis, mx equals 400, my equals 500, and vertical load 2000. Still, we're going to use the equation 10.1 to figure out the bearing capacity of this foundation. But before we proceed to the determination of these bearing capacity factors and modification factors, we need to determine B prime and L prime. B prime and L prime are introduced to correct the dimension of footing affected by bending moment. It's easy to understand that this bending moment X increases the pressure between the footing and the soil on this side, and for this bending moment My, it increases the pressure between the footing and the soil on this side, which means the pressure distribution under the bottom of the footing is redistributed. This is a new B prime and the new L prime. The equation used to determine B prime and L prime is that B prime is equals B minus 2 times mx divided by P, and L prime equals L minus 2 times my divided by P. After you get these two effective values determined, you need to compare if B prime smaller than L prime, use B prime as B prime and L prime as L prime. Else, if B prime is greater than L prime, then you use B prime as L prime and L prime as B prime. In one word, the width of the footing should be smaller than the length of the footing. Then we can proceed to equation 10.1 to solve for the element bearing capacity QU. And in this equation, you will use the effective cohesion C prime phi prime for these factors of bearing capacity and factors, and B prime, L prime, and D for S factors, except for depth, factor correction. And QS equals the effective vertical stress in the soil at a bottom level of the footing.